Hello folks, and if you can hear me over the noise of the printer behind me, which is doing 68 pages, here we go with the Rotel RVC240. Just thinking what the date is. We'll put down the 10th, it sounds about right. Rotel RVC240. Have a look at the serial number. You'll never guess who it belongs to. 111008547, and it's Steve's. He's a radio ham friend of mine and has a collection of CB radios. So you get the smaller speaker in the Rotels than you do in the Fidelity 2000, and the RV240 and the Binatone 5-star. So this would be, if this was Binatone, it would be Binatone 4.5-star. So we're going to do the VCO. That's why I've got the meter out, and I've got a little stub of a power lead on here for doing Cybernet sets. Don't forget we're doing that PNI when we get parts for that. So this is kind of in between, which is why there was a part 1 and going to be a part 2 for that. We've got a power supply from our mystery benefactor Alan, which we'll be sorting out. It's one of those banned Taiwanese ones, so I enjoy those. And it works so well once the safety issues have been addressed. Though of course they don't work as well as they say on the lid. But what's new there? Right, I've got it connected to our famous crocodile clips, which I regularly short out. Power on, 13.8 volts, no safety issues because I know Steve's already had a quick look. Just plug the PA speaker in. It's come with the original mic, but we're going to use our standard replacement mic, but we'll test the factory original mic. In fact, I'll tell you what, we'll test it right now. When I say test it, we'll check it, the deviation's right. With it, we're going to check that it, when we go through to the base station on the air test, we're going to test it then. So normal, that needs to be there. Testing 1 2, testing 1 2, 1 2 1 2 1 2 1 2. Good. So now, oh yes, he couldn't get the teeny weeny screw in, could he? Testing 1 2. That sounds, without changing the volume level, it does sound louder on our standard replacement. So I'll be mindful of that when I do the deviation. No idea where all the clipboards have gone. Probably to the taxman. Right. PA works. Meter lamp works. It's a good start. Plug the test equipment into the... Did I tell you I've got 15 minutes? Right, so we'll switch, make sure it's on channel 40. So I've covered this time and time again, VCO, but we will once again resistor 4. Going to zoom in once again, even though we've done it on the last video. Especially when I find the right camera. There we go. Resistor 4 is this one. And it's the far end. So our earth we'll pick off, because the chassis isn't earth on these. pick on that strap across the transformers there. So we'll get our earth onto there. We'll switch our trusty little multimeter on, and then I'll zoom out when you see where my probe is. So the far side is there, and I'm getting 4.19 volts. So I'm going to zoom out to show you. So that's fine, we don't need to alter that. And on transmit, it's 4.3, which is absolutely fine. Just verify it. It's supposed to be 4. Just verify it on channel 1. Should be between 1.8 and 2.3. And we are at, on receive, 2.26, and on transmit, it's just slightly higher, but I'm not going to alter it. Because the danger is, just take this off, this is 40-year-old set. The variable capacitor there is the setting point for this red variable capacitor. I'm gonna zoom in again for people who don't know about this, which is just neatly out of shot. That wire wants to be there, doesn't it? So we've got this red variable capacitor, which is the transmit trimmer for VCO. Now, after 40 years, it's quite possible that that's got dirt in it or whatever. So I'd rather not move it if I don't have to move it. And I don't have to move it because it's so close. The receive one is there. Normally they're wax filled, that one isn't, but it hasn't been played with. So that's absolutely fine. So I'm going to put 4.4 for both. Now what you don't want is to find that one's 6 point something and one's 2 point something at channel 40. So it's channel 40 for 4 volts, and then you go back to channel 1 and verify that it's between 1.8 and 2.3. And that means 1.7 to 2.4. It's not that critical. Let's go back to the normal position. So it's I'm going to put 4.4 plus 4.4, and it's 4.4 plus 4.4. I'm not changing it. So let's look at the frequency next, if the radio transmits, that is. Why I'm pointing the remote at the test set when the cameras are all around me. Bizarre. So, frequency 27. Oh, we're still on channel 1. Go to channel 20. So everything else is done on channel 20. 27, 79110 is pretty close. We'll just pull it up a bit with the red trimmer capacitor next to the reference crystal. Whichever way I turn it will be the wrong way, because it always is. Because it can be either way. So again, what I said with the trimmer capacitor, that didn't really need changing, but for the demonstration I have done. Right, so let's see what power it's doing on transmit. So I'll switch to the 3 watt scale. It should be full scale deflection. It's just full scale defection. Defection? That's what people do when they go from one country to another. I remember the story of somebody in Ireland, coming to Ireland, somebody from another country, and they went up to a policeman. He said, and the man, there was a man and a woman with broken English. He said, "We want protection." So he radioed for assistance to get them into some kind of scheme to help them. And in actual fact, what the guy wanted was to buy some condoms. He didn't want to defect from another country at all. 3.1 watts on channel 20. Let's go to channel 40. .05 on channel 1. 3.15. Low power, let's go back to channel 20. Either my printer's finished or it's run out of paper, one or the other. It's not working on low power. Oops, it's there. And on transmit, on full power, we are drawing how much current? 1 amp exactly. Exactly 1. Okay, so we'll just go through the transmitter, making sure we're still on channel 20, which we are. So 1, 2, 3, and then the 3 in the PA, power amplifier. We need to balance these regardless of how many watts it's doing. So they're in the centre. We don't want the set to be lopsided. It's slightly lopsided at the moment, but it's acceptably lopsided. They'd like it to be within 0.1 of a watt between channel 1 and 40, and it's certainly doing that. It is supposed to do 3.8 watts, although of course we're going to turn it up to 4 if that's possible. Okay, so that's now still 3.1 watts, but we have made sure it's balanced. So with the 3 here, we need to, is that broken? What the idea here is to peak these to absolute maximum, but you've got to be quick doing this because the transmitter can't support absolute maximum power for very long. So it's very heartbreaking when you see a radio that's been left in full whack because they think they're tweaking it up in inverted, can we do the inverted commas? Tweaking it up in inverted commas, but it's not designed to do that, and then you end up with blown transistors for no reason. Because all this makes absolutely no difference to your range. The difference between 3 and 4 watts is, we've demonstrated this time and time before on the air test, it's pretty marginal. Can never remember which tool it is. That one fits. So, key up. I may as well do this one. That's peak. That's not shifting. That's not shifting. Nothing's shifting that one. See if we can peak that one. Nope. Right, have we got the other kit with the blue one? Okay, so we've got 5.1 at the moment. Peak that again. It's dropping quite rapidly because it can't support it. There we are, 5.1. So the idea now is to take the yellow one clockwise to the right, in other words, to 4.4 watts, which is there, and then the green one anti-clockwise. The manual says to 3.8 watts, but you're entitled to 4, so we may as well have it. Remember, it's so they can get these radios through customs, but they're always set low, and they still are set low. The supplying dealer is supposed to adjust them, but the supplying dealer doesn't usually. There are one or two who do, But it's all about box shifting, isn't it? And the best possible price. I remember when we had a television shop in Yorkshire, and we used to pre-delivery inspect all the new sets which came through, and I'd actually have them on for 40 hours, and then we would do some final power supply adjustments, put them back in the box and stamp them PDI. So lady came in for a television, and she said, have you got a... We did Ferguson, we did HMV, so both Thorn products, and we're going back to the days of... Well, we're going back to days of the TX9 was new out, and the TX10 followed it, and we'd packed up by the TX100 came out. You know, we're going back to that kind of era. I think it was a Thorn 8800. Yeah, it was Thorn 8800 under the Ferguson brand. Just got it all... It was like... It had been on test for something like 38 hours. She said, have you got a Ferguson such and such? I said, I have. And I think that's 369 quid for a set, you know, with a simple remote control, channel advance and channel mute and sound mute. And 22 inch. And I said, actually, I've just got one completing its test now. I said, if you've got 10 minutes, we'll put it back in its box for you. Oh, no, I want one, a new one in a sealed box. So I said, well, we set the power supplies up so that they run cool, etc. Because the trick was, if you rented a telly, they ran the power supply cool. If you bought a telly, especially Comet, they set the power supply as high as they dare. So on these sets, I think it was 204 volts, the power supply. So if you set it to 212 volts, then the television would run hot and not last as long. And if you set it to 197 volts, the picture just filled the screen, and it ran cool. So if you're renting them out, the idea was you set them to 197, and if you were selling them, you set them to 212. But we set them to 197 for everybody because, you know, that's the way we work. But she wasn't going to have it, so I gave her one out of a box. So goodness knows how that lasted, but it wouldn't have been the 15 years we like to get out of people's tellies. Right, so we now are at 4 watts. And let's look at channel 40, 4 watts. Let's look at channel 1, 4 watts. I got it right today. Clever Tango. Four watt, 4 watt, 4 watt. Low power. Oh no, we'll do current consumption while we're at 1.15. So for another 150 milliamps, we've got nearly another watt, haven't we, out of it, which is great. Low power has probably got a malfunction. It's probably got a malfunction because of a dirty preset, so we'll just put some service on that. Sometimes the presets die and we have to change them. Let's see what happens now. So we're going to low power if I can find the switch. It's one thing I don't like about sets with lots of switches and knobs. No, we've got absolutely nothing. So have we got a dirty switch? Let's give it a waggle. Just a self-cleaning with them having wiping contacts. High power, low power. Yep. I think we need to change the preset on that. But I could just make it do a bit. So we'll change the preset, turn the meter off, put the meter away. I'm going to do a cassette tape today for, you know, one of these vintage cassette tapes. David Quotagus has kindly, go on the floor then, has kindly copied one for me, or for us. So back to 4 watts, let's have a look what the meter says on the front. It goes boing right across, so we'll just adjust, that's it. So 4 on the radio, remember it's relative to SWR, so it only reads 4 when it's on dummy load. It might read 2 when it's on an error, it might bang across when it's on an error, but the radio is still doing 4 watts. We'll just set this deviation. I want that to the center position, and this is then the deviation, that's your AGC. So, see where the deviation is. Don't believe the Marconi tests are always. Wallow. It says it's 1.6. That's quite possible. Wallow. And that is a peak of 2.5. But we don't trust it because it could do with the capacitors changing. And 1 in 10 times it doesn't work right. So we can't trust that. So it's easier to plug into the test set behind me. With 2 test benches in this room. Drops mic on floor. Let's see what it says. Wallow. It's over the top. It's 3. So it was about right as it was. Wallow. Good. So the Marconi one is playing up today. So it was, I'll just put a note there, faulty preset. So it was 2 dead. And in fact it's now 2.2 to 2.5 kilohertz. It was 27,79111. It's now 27,79125. The RF meter was 6 and it's now 4. So far all that's fine, that works. So we really just got the fault to sort out, but we'll do the receiver when I come back from what I've got to do next. Okay, so back with this, we've got the printer doing 168 pages now. So change this preset, out you come. That's the knackered one. We get these from, where do we get them from? Because the skeleton preset's hard to come by. Rapid Electronics, Rapid Online. The solder's always going on the floor. Well, I think we can put the bottom lid on. I might even put some screws in it. Put the rest in later. Okay, so back to trying to set this up. So, low power, select low power, key up, and there we have 400 milliwatts. And then we'll go back to, oh no, I'm in the wrong, I was 4 watts. That's 400 milliwatts. Now when I go to full power, we'll bang across. When I go into the other scale, we've got 4 watts. Right, receiver time. Set the signal generator. Let's go over to the frequency counter and we can set this up together. 2779125. And the oscilloscope and SINAD meter on. Let's have a look at what we've got on the SINAD meter. Turn some volume up so we've got a meaningful reading. Tell you what, it's really good. Just make sure its RF gain's at full. It wasn't. Right, SINAD meter on the inset picture. So for 12 dB, well, I've never seen one like this. It's 0.2. For 10 dB, I have to go down a scale. And this is the trouble when you go down a scale, because the calibration can be different, so we're going to call it 0.2 again. So we'll go back to normal scale, and 20 dB is a rather healthy 0.55. I don't think I've seen a Rotel 240 as good as this. You get the odd Binatone 5-star and Harvard 420 and SMC Oscar One. But I never found the Rotels actually as good as some of the Fidelity 2000, for example. Right, well, I don't think there can be much going to be needing adjusting on this with that kind of result. Wow, we go to the oscilloscope, which is camera 3, and Q. Put 100 microvolts on the signal generator. Just get the volume such that we've got a right kind of trace. I don't need to bother adjusting the oscilloscope, adjust the volume on the radio, and the oscilloscope's just connected across the extension speaker. So we need to check the detector. There's the detector coil. Tell you what, it was slightly out. Now that might be why it's showing more sensitivity than you'd expect. But at least it's going to be spot on audibly now. But tell you what, I'm just going back to let's go to the SINAD meter, and it's still incredible. Right, we've got to find about 2 dB, 4 dB, sorry. We'll go through this. No improvement. No improvement. No improvement. I'm going to go for bigger signal now for these. And the hiding one down there. So let's get a new reading. Well, it's just showing less than 0.2. We'll change scales. It'll still be 2, won't it? Yeah. I can't really. It's going to be about 0.19 or something like that. Because I can't reliably say. So 0.2 it is, and for 0.52. So there was some improvement. It's less than 0.2. Squelch, never check that. It's a bit weak at 30. Is it 30 microvolts? It's 25 microvolts. And threshold is 0.82. Right, so we need to just jack that up a bit. So I've got 30 microvolts on the test set. I want to squelch that out. Let's go over to the attenuator so you can see that. So with 30, 0. Squelch preset. Now I'm going to turn the attenuator to 100, having silenced it on the radio. Yep, that's now 100 microvolts, which is where I want it. There's no hard and fast rule to this, but that's where I feel it should be. And now, where's threshold gone? Let's have a look. It's actually 0.5. It's exceptionally good, this set. I mean, I've seen Rotel 240s, and you're struggling to get much better than 1 microvolt, which is still better than things like those Cobra 29 XL whatevers, which we've seen do 2.5 microvolts. And the meter should be 9, and the meter is 9, so I'm not going to adjust it. That's it, we're done. The preset for the meter is there. What a lovely set. This is going to whistle round Scratchy Corner. It's not going to be scratchy. I've had some cable come today. I've not had industrial grade like I normally do. I had ham radio grade to do the base station area on the back of our chapel. So I want to get that over and done with. So I want to put every Cobra set that has been legal in the UK on a table and compare how they get worse and worse the newer they get. I think that's a great video. Right folks, well that's put back together. Let's see where my deviation is on the Marconi test set, just in case the machine is giving an accurate reading now. 1 to all, at least 1.8, so it's lying. And what we're going to do is just compare that with the deviation from the factory original mic. Wow, it's the same. We'll sort his screw out later. In the meantime, we'll put it on the aerial and see if there's any good or bad bruddies out there. I'll put it on its own speaker. Turn the test gear off, save some electricity. We have a solar panel scheme here which generates 3 kilowatts, so try and do everything in the day, like run the dishwasher. 19 Roger. Now you've seen how sensitive this set is. 0. Don't know what that is. One on a Roger. There you go. Nobody on. Good. Right, well, I look forward to doing the on the air test for that later. Thanks for watching Rotel RVC240 from 1981.